Once again, welcome you all for this 2 days certified bootcamp uh, with the fundamentals of electric vehicles. Before I start, I would like to kind of give you some idea about what is Skill-Lync. Obviously, many of you might be knowing what we are doing. We basically try to help a student to become an engineer. So those who are engineering students in mechanical, electrical, civil and computer science and other related disciplines, we help them with our online courses. So we are an e-learning platform and we help them to become an engineer through the courses, right? So our courses are industry oriented and practice based, project based learning approach. That is what we have. And I will quickly go through this and then we'll start with the bootcamp. I'm assuming many of you will know about Skill-Lync. So guys, we have around 80 plus courses and which basically helps you to get trained for 50 plus job roles in all this discipline. That's what I discussed earlier. And we have students across the world and across all the parts of India as well. So we have a large reach of 5,000 plus students across US, Europe, and India. So yeah, so thanks for joining this meeting. Let us start with what you are going to learn today. Okay, so let me tell you the agenda for both of these days. So we have first day, I will be covering why electric vehicles, why people are talking about EVs nowadays, and why you have so much of news articles and so many things happening around you with electric vehicles. And we will discuss about what are the technology trends and what are the unsolved challenges in automotive electrifications, right? We will also talk about what is the energy flow and what is the overall efficiency of electric vehicle. And we'll also discuss about how do you start learning about electric vehicles, right? From where we need to start. So this is about day one, and day two you are going to learn about battery technology, and we will do one simulation of electric vehicle battery pack as well, which is the agenda for second day, that is tomorrow. So let's get started, and I would like to interact with you all in order to understand about your perspective, your opinion, and I may ask basic questions. At the same time, you are also um, uh, you can equally ask the questions to myself, and I will tell you exactly when at what time I'm looking at the chat box, and probably I will take a pause frequently and allow you to ask questions related to whatever we are discussing. So yes, let's get started with the first topic on day one. Why electric vehicles? So guys, are you aware of, let's say, electric vehicles are made up of battery and motors, right? So they are motorized vehicle, or we can say it's a motor drive replacing the conventional engine for movement of the vehicle. Now, when you say electric vehicles, why not electric vehicles till now, right? So I would like to ask another question. Instead of why electric vehicles now, I would like to ask the same question. Why not electric vehicles till today? Okay, or what are the problems? Why we haven't seen electric vehicles till today? So I would like to see your opinion, guys. And uh, okay, so okay. So Madhu Smita is replying high cost. Okay. Bhavani Singh due to lack of charging points. Okay, that is one of the reason. Sonu battery life, correct. Okay. And lack of efficient batteries. Okay. cost and range, infrastructure, pollution control. Okay. Yes, cost and charging issues. Okay, great. Thanks a lot, guys, for your answers. Um, so Sayed is asking about, in his opinion, it's maintenance. Uh, no, it's not maintenance, which is a challenge actually. Or we will talk about that as well. So EVs are actually um, having less maintenance compared to IC engine vehicles. Pratik is implying public awareness. Oh, great. So Pratik, I agree with you. Many people doesn't know. Many people are not aware about. Yes, they have an option of EV when they are selecting a vehicle for themselves. Yes, I agree with you. Great. So thanks a lot, guys. I will stop looking at the chat box. There is one thing somebody saying their reliability in long distance. Okay. So Sangesh is replying the reliability in long distance. I will also consider the reliability in long life. Okay. So we are going to do this exercise today, and we will see where EV stands today. Okay. So let us go with why don't we see many electric vehicles on the road? And this is another question: why EVs today? Right? Why we are talking about EVs today? That also we will answer. We'll look at the both dark side and the bright side of EVs in this session. So yes, I agree with many of you, and the fact or the reality is that hardly 1 or 2% of the uh, total vehicles are fully electric vehicle. Okay, as on today, across the world, right? When I say 1 or 2%, it is across the world, in all the countries. If you take all the vehicles, mostly we are talking about here four-wheelers, there are hardly 1 to 2%, like, sometimes in some countries, even below 1%, vehicles are electric vehicles. So what is the reason? Let us list out the reasons. The reasons are the total onboard energy available is very low, and therefore the range issue. Okay, so if I talk about, let's say you have a petrol car, and in a petrol car, if you are going to let's say your petrol tank capacity is, let's say, 20 liters, right, or 30 liters, then if you want to carry that much amount of energy, which is available in the petrol as a fuel, as a chemical energy, if you want to carry that much amount of energy in an electric vehicle in the batteries, right, it's next to impossible, right? So uh, watt hours per liter is the biggest challenge, and that is something we also call it as energy density, right? So how much is the energy available in the volume area or in the liter, right? That is very, very low, even for today's lithium ion batteries, right? So the onboard energy available is very low, and therefore the EVs suffer from the range, where the range is practical range nowadays is around 200 to 250 kilometers. But if you take a full tank, probably if your mileage is better, your driving conditions are better, you may be able to travel with your car around 300, 400 kilometers per full tank of your petrol. So this is one of the reason the onboard energy is very low compared to the conventional fuels, and the technology is still under development. Okay, so motors probably are, let's say, hundreds of years ago, people started using motor, and the motor technology got matured. Battery technology is also quite matured, right? When you have a battery technology available, when you have a motor and drive technology available, why these two things cannot be integrated together, and why electric vehicles are not there? in the world, right? Since many years, right? So motors are available since years, batteries are available since years. Why EV is not available since many years? The second point is one of the major reason, and also the cost of such a battery, where you have a equivalent high amount of energy. So the next reason is obviously the lack of infrastructure. When I talk about, let's say, the lithium-ion batteries are available, but can we electrify all vehicles in the world? Probably it's uh, addressable question, right? Or the raw material for the lithium-ion batteries are available, but how can all vehicles requirement of the battery can be satisfied with this much of raw material, right? Do we have that many factories producing battery cells? Do we have that many charging stations? Do we have the human resources who know how to work on the EV technologies? Yes, this is another challenge: lack of infrastructure and limited service and the maintenance and support. Yes, obviously, uh, it is one of the reasons, right? So if you look at India in 2001 to 2003, like almost 20 years ago, people came up with electric scooter, right? So electric scooters are in India since 20 years. But probably you will not be knowing how many brands of electric scooters or electric vehicles are available in two-wheeler category as on today, right? So yes, one of the reason is limited service and the maintenance support. People don't know if your electric scooter gets punctured, how to replace the wheel or how to take out the tube from the tire. Nowadays, there are tubeless tires, but there were such a problem earlier, right? So the service and the maintenance support is also another reason. So these are one of the list of reasons why we don't see electric vehicles on road, and the list is actually endless. Now we are going to see why EVs are becoming popular, why there is a shift in the EV technology, and what exactly we are expecting to happen. Okay, so before that, I would like to see if any of you have any questions, right? So I think let me check out the chat box. Okay, so guys, if you have any questions for this particular uh, slide, right? If you have any questions, feel free to ask. I know a couple of people have raised their hand. So due to high number of participants, we will not be allowing you to unmute yourself. Feel free to type your question in the chat box. I would like to uh, address this. Okay, so Rajkumar is asking how EV is reliable for city mobility. Yes, Raj. So EVs are reliable for within the city transfer as well. And nowadays, a lot of vehicles are coming in the EV category. And so, why do we use lithium ion only in the EVs? Yes, it's a good question, Madhusmita. So, if let's say if at all you want to use lead acid battery in an electric bus, okay, for example, and you want that bus to travel for around 80 kilometers, for example, and if that is a bus which is designed a lot with lead acid battery, probably there is no space for passengers. Okay, so if you have a vehicle, right, where the space is a constraint, uh, the lead acid batteries are going to be very heavy and they are going to occupy a lot of space. Okay, so the lead acid batteries do not have that much of high energy density, although there are vehicles which are, let's say, uh, low duty vehicles or low capacity vehicles such as two wheelers. The lead acid batteries are equally popular even today. So Lokesh is asking high electricity is needed. Lokesh, if you are asking about the type of power supply, yes, you need a three-phase power supply for charging a vehicle such as maybe a car if you are using a fast charger. If you are using a simple charger, then single phase supply of 20 ampere outlet is enough. So it does not need high electricity, but my answer will be, it depends on how you are going to charge it. Okay. So, okay. So Ajit is asking, what is the meaning of watt hour per liter? Okay. So let me explain you, Ajit. Watt hours per liter is basically the measure of how much energy is inside the battery according with reference to its volume. Okay. So if I take 1 liter of petrol in a bottle, right, and it's just going to be that small bottle. But if I take the similar amount of energy which is in 1 liter of petrol, if I take similar amount of energy in, with a battery, right, let's say lead acid or lithium ion battery, it's going to be very, very large. It's not going to be as compact as a small bottle of a 1 liter, right? So watt hour per liter is basically how much amount of energy is contained in a battery. Okay, so thanks a lot, guys. I see a lot of questions. I would like to take those charging station related questions later, and probably um, let me know your questions whenever we talk about that topic. Okay, so thanks a lot, guys. Alok is asking about regenerative braking. Yes, we will come back to that point. Which process is used to recycle? Shubham, yeah, we will discuss that. Guys, these are upcoming batteries. Uh, and Rajkumar is asking, is watt hour per liter means mileage? No, Rajkumar, it doesn't mean mileage. It is just how much energy is contained inside the battery. Okay, so thanks a lot, guys, for asking this question. I'm no longer going to have a look at the chat box. Let me go with the next slide, where we are talking about IC engine vehicles, right? So here I'm showing one picture, and this picture is actually the cut section view of Honda two-wheeler engine. Okay, so Honda Activa, which is one of the popular two-wheeler in India, you see a lot of components in the engine, right? This is a black color silencer, and probably there are a lot of components like piston and CVT on that side. And here is one component which is basically your starter generator, right? So I'm talking about this component. Let me use the blue color. So this is a component which I'm highlighting in the blue color, which is basically a dynamo, right? How you help your engine start. So these two-wheelers are available in both kickstart and auto start. When you use auto start, it is going to take power from the battery, and it is going to try to spin the engine and start the engine. Okay, so starting the engine is by default an electrical activity, right? So or you take any vehicle, right? Or even if you take any standby diesel engine, right? How you start your engine, right? It's all electric start, and therefore I can say all vehicles are electrical in nature to some extent. Okay, so engine and electrical machine, where it's a motor and generator, they are very old friends, right? How can I say this? We are using motors and batteries to start the engine since years, right? So let's say if engines are 100 years old, we are almost using batteries and motor to start them since let's say 50 years, right? Or let's say 30 to 40 years from now, right? So engine and the electrical machines are very old friends, right? So motors and batteries help the engine to start. Okay, now what else? Once the engine is started, now that battery is going to be charged. So the same motor or the same electrical machine is going to act as a motor as well as generator, and therefore they are called as integrated starter generators. So all engines nowadays need the electrical help. Okay, so if you have seen a recent two-wheeler, let's say Bajaj Pulsar, there is no kickstart. Okay, so the kickstart has been obsolete in the recent vehicles, and almost all engines need electrical help to start. And therefore, I can say all the vehicles are hybrid vehicle to some extent. And when I say all vehicles are hybrid, uh, we mean that all the vehicles will have battery and motor by default. And whether the engine is there or not, it depends whether you call that as a hybrid vehicle or pure electric vehicle. So the difference between hybrid electric vehicle and the pure electric vehicle is how your vehicle powertrain is configured, right? So if you have engine along with the battery and the motor, it's called a hybrid electric vehicle. If you do not have engine and if your battery and the motor are very powerful, then it's called all electric vehicle. So if I give you an example, if this particular block, right, if this particular block highlighted is very powerful, it is as capable as engine. So let's say this Activa engine is of 5 HP to 7 HP, right? If I have a 7 HP motor or 5 HP motor, which can replace this engine, which can produce that much of speed and torque, I can see this vehicle as a electric vehicle, right? So if the battery and motor are powerful, we can replace the engine at all, right? And there is no need for engine at all. And that type of vehicle is called pure electric vehicle. So I hope you guys have clear understanding about electric and hybrid electric vehicle. Let us go ahead and see what is the difference. So IC engine vehicles are basically less efficient, and electric vehicles are very high energy efficiency vehicles. IC engine, on the other hand, it's a mature technology. Electric is still new technology, right? I will say not a new technology, but a successful technology which is new, right? So, and again, it's very costly, right? So we will see about this as well. And energy resources and the infrastructure are in place, right? So these things are very well taken care of. So if you are buying a petrol and diesel car, you are not going to worry about how you are going to take the fuel, right? So the petrol pump infrastructure is available across the cities and highways and everywhere, right? So the energy resource infrastructure is in place. On the other hand, battery related infrastructure or the charging related infrastructure is still under development. And when you say hybrid electric vehicle, it is going to lie somewhere in between. So hybrid electric vehicle will be the category where you have the mixture of this two, where you use engine as well and you use electric motor and the battery as well, and that is called hybrid electric vehicle. So now, when we have understood all IC engine vehicles are basically hybrid in nature because they take help of battery and motor to start. And the difference in the electric and hybrid electric vehicle is about the energy efficiency, right? So let us have a look at this. Okay, let us have the fundamental understanding of this first point. IC engines are less efficient that we know, right? How electric are very high efficiency, right? So let us try to understand this point, and then we'll go ahead with knowing about efficiency of each level. Okay, so when I talk about efficiency, the efficiency actually lies in two things, right? How much of energy you have available, which is stored energy, and how much of energy you want on the wheels. Okay, and what is the conversion ratio? Okay, so when I take IC engine, basically I have petrol or diesel as a stored energy, right? And when you convert this petrol and diesel into the motion on the wheels, right, you need to kind of understand what happens in between. Okay, so let's say this is a wheel and this is the energy stored in a petrol and diesel. What is the conversion factor here? Okay, so now there are a lot of conversions happening here. So first you are going to burn the fuel, so the chemical energy will be converted into thermal. Then the thermal will be converted into mechanical. Again, mechanical will be transmitted to the wheel. Okay, so this is a three-stage conversion. Now, what about electric? Electric is two-stage conversion only, right? So you have a battery as the energy storage element, and when you have the battery, it's basically producing the electrical power. And most of the batteries are highly efficient. So the amount of charge you put in, the similar amount of discharge you can take, right? So batteries are almost 90 to 95% when you come to charge and discharge, or when you, let's say, take a self-discharge rate, or when you take a leakage current, batteries are very, very better in terms of energy storage. So batteries are going to produce electrical energy. And now I do not consider the chemical energy to electrical energy as conversion, right? Because it's already stored as electrical energy, right? So batteries are already having the electrical energy stored, and there is only one conversion required from electrical to mechanical. So unlike IC engine, which has chemical to thermal, thermal to mechanical, here IC engine based, electric vehicles require only one conversion, which is electrical to mechanical. And therefore, this is going to be two-stage conversion, right? So here, the amount of energy conversions are three. In case of a petrol vehicle, here there are two-stage conversion, and therefore, electric is high efficiency. So now what about the efficiency? This can be a three-stage and it can be also higher. This can be a two-stage and this can be also of lower, right? So it doesn't actually mean that number of stages, but it actually means that electrical to mechanical, when it comes to motors, they are very, very efficient. So if you talk about any applications, let's say you talk about cranes, right? Earlier people were using hydraulics and pneumatics. Or if you talk about any application, let's say elevators, you will see everything is motorized, right? Because motors are of high efficiency. So any mechanical work that you want to do, that is done by motors, right? And therefore, motors are replacing most of the mechanisms which are hydraulics and pneumatics. Okay, so electric motors are very mature technology, and they are more efficient, and therefore electric vehicles are efficient. So now let us look into the fact that how electric vehicles are going to be there in the future. Okay, so I'm going to now talk about the forecast. So we have seen the comparison of IC engine vehicles along with electric vehicles. What is going to happen in future, right? So here I'm sharing with you a Boston Consulting Group survey results, right? And it shows till 2020, there is 1% of the vehicle which are battery electric vehicle, which you can see in the orange color. The green color is gasoline, which is basically petrol vehicle. The other different type of a blue color is for diesel, and you can see a lot of diesel vehicles are still there, and rest of them are HEVs, right? So between diesel vehicles and the orange, which is electric, there are three types of hybrid electric vehicles, which are mild hybrid, full hybrid vehicle, and plug-in hybrid vehicles, right? So we are not going to discuss about the difference of this, but you consider this as a combination of IC engine along with the battery in the motor of higher capacity. So if you see this difference, right, what is going to happen? EVs are not going to replace all the IC engine vehicles in near future, right? Because it could have been done like a very quick transition, but we are on the verge of a new technology adoption, right? So how we are on the verge of new technology adoption and how it is going to affect. So there are two major impact, or there are two major reasons, right, why people are, or why the technology penetration is going to be electric, right? So the first penetration is going to be regulation driven. What is the meaning of a regulation? The regulation is, for example, the climate change regulations, right, or pollution control regulations. So recently, or let's say 1 year back, or 1.5 years back, government announced that we need all vehicles which has to be BS6 certified, right? So that is a new regulation, or that is a new kind of rule by the government, that your vehicle, or the vehicle you are going to manufacture, that should not produce this much amount of pollution. So now that is a BS6 regulation for petrol vehicles. The government can come up with certain regulations even for electric vehicles. Now, what kind of regulations it can be? Initially, this is only subsidy driven, where I can say, the government is going to help EVs to promote, right? Government is going to help customers buy more electric vehicles by providing incentives, right? And there is a recent announcement with a FAME 2 subsidy announcement, right? And people are looking at it, how EVs can be more affordable at the customer end, right? So this 5 years, from 2021 to 2025, till this point of time, we can see this change, or this rise in the orange bar, right? Or the number of EVs is going to be subsidy driven or regulation driven, and later period it is going to be customer driven. Okay, so this is TCO driven. Basically, the TCO stands for total cost of ownership. Because electric vehicles are very efficient, right? Their running cost is very, very low. And the total cost of ownership can actually come down to your petrol and diesel vehicle, right? And which means that EVs are more affordable. Okay, so we are going to see this in detail. What is the meaning of total cost of ownership? But in the long term, let's say 5 years from now, is going to be driven by totally the supplier and the consumer, right? Which is the companies who are manufacturing the EVs, and the buyers or customers who are going to buy the EVs, right? So it will be totally buyer and seller market. There will not be any intervention of the government or any authority, right? So total cost of ownership is something where customers who are interested in buying this will be evaluating how much affordable is the electric vehicle. Okay, so I hope you guys are able to follow this, and this is the overall forecast where you can see a lot of rise, or you can see a lot of penetration of hybrid electric vehicle as well, right? So if you see this hybrid electric vehicle as on 2021, which is this much, if you see after probably 5 years, the hybrid electric vehicles are going to be around 10% of total, right? So, and overall, if you see another important fact, right? The another important fact is the number of vehicles. So in 2015, we are having, let's say, 87 millions of vehicles, or not all the vehicles, but only car. Okay, so by the year 2015, we had 87 millions of cars on roads across the world. It is 100 by the year 2021, and it is going to 109 by the year 2030. So, and if you have seen this trend, let's say if you are talking about the year 2000 here, right, the number of cars available has grown very exponentially, right? So this curve actually was very steep in this year, and now the number of vehicles are going to be saturated, right? Because the only reason is now you are going to have a shared mobility. So now, instead of you owning the vehicle, there are customers who are looking for an option where they can just take the service of a vehicle, right? This is obviously a debatable question, whether you will own your four-wheeler or you will be using Ola and Uber throughout your lifetime, right? So yeah, and if you have that much of money to be used for Ola and Uber, uh, which is equivalent to your private car, probably you can travel across whatever are your travel requirements, right? And but there are pros and cons of that. But yes, number of vehicles now onwards are going to not increase to that extent, right? So we have now many vehicles, and people are looking of not only electric mobility but shared mobility as well. So the percentage hike from year 2000 to 2020 is not going to be now to 2020 to 2040, right? So that's another comment I would like to add here. And let us go ahead and let us focus more on what is total cost of ownership. So on the right side of my presentation, I'm sharing one image of 2019 Honda Civic LX, which is a petrol vehicle. And there is equivalent electric vehicle. I will not say exactly equivalent, but yeah, a similar vehicle, which is Nissan Leaf. And if you take the total cost of ownership, right, then it is going to result into this much of price. Okay, so the total cost of ownership for EVs are better. So I would like to ask the same question. Just have a look at the right side of the screen, and where I'm sharing a total cost of ownership. Are EVs affordable to customers? So I will be looking at the chat box now, and I would like to understand, what do you think? Do you think EVs are affordable to customers now? Uh, Maybe you can take this as a reference, where we have 2019 Honda Civic and 2019 Nissan Leaf. This is a typical total cost of ownership comparison for US cars, right? So this is for a typical country and typical category of the vehicle, but you can definitely come up with a total cost of ownership for your type of vehicle in your country. So do you think EVs are affordable by looking at what I'm showing in the slide now? So Gautam is saying, yes, they are affordable for the long term. Okay. So fine. Okay. Rituraj is saying yes. JK is saying not affordable. Madhusmita, no, still much more costlier than IC engine. Okay. So yes, here I can see a 50-50 yes, no. This is really a great situation to take a debate from here. Okay, so Sharon is saying that definitely not, EVs are not affordable. When considered to our country, we need to consider import duties and fees. Oh, okay. Pratik is saying, I think HEVs an added advantage is that HEV more range than EV. Okay. For EV, we have to think about the range these days. Okay. So Pratik, you are trying to compare HEVs and EVs here. Okay, fine. So, but what I'm showing here is IC engine and EV. So, okay. Gaurav is saying not now, but maybe in future. Okay. Ramesh is saying long rides in EV is not possible. Okay. Yes, Sandeep is coming up with an important point. What about resale value? Yes, that's obviously a great point. Okay, great. So thanks a lot, guys. I can see a lot of opinion, but Anand is one of the curious learner or one of the curious person. How is cost calculated? Okay, so Anand is asking a really interesting question. How do I calculate my total cost of ownership? So let me explain you in this slide. and let me throw some light on that. So guys, I'm not going to now look at the chat box. So thanks for your opinions. So what you are actually going to do with a TCO, right, or a total cost of ownership, it is basically uh, how much you are spending, right, on your vehicle, right, in a simple word. So economy is the driving factor, right? So customers are going to look at the items or the products which are more affordable, right? And economy is going to be the driving factor. And and before I explain total cost of ownership, I would like to also add one more point. Uh, EVs are definitely costly, but why shouldn't EVs not become costly, right? Let's say you think of your cell phone, right? You had a keypad-based cell phones, right? Probably in the range of 2,000 rupees to 3,000 rupees, right? Now you have a touchscreen phone, and people are spending a lot with a touchscreen phone because it's not just a phone; it's a smartphone, and probably you can do a lot many things. Now, if anything is to be replaced with a new technology which is better, right? Why shouldn't it be costly, right? So why should people be worried about the cost, right? Because there are a lot of benefits to that, right? But even though the mindset is, or even though the buyers are inclined towards comparing, right? And even if you are in the place or I am in the place, uh, when I am deciding to buy a two-wheeler for my family member or myself, I'm going to do this calculation, right, in one or other way, right? So what is that calculation? So many of us do not do that calculation because we don't know EV is an option available to us. Electric two-wheelers are available in most of the cities and even small towns in India. But we don't do that calculation, right? So what is it that calculation the customer is going to do before buying? That is called a TCO, total cost of ownership. So if you see the 2019 Honda Civic, its on-road price, right, or a sticker price is, let's say, 23,000 US dollars, and for Nissan Leaf it is 36,000, right? And guys, if we are talking about Tesla, which is very popular, you might have heard of it. Uh, it starts from it's a luxury sports car, and it starts from 75,000 US dollar. So yeah, there are affordable Tesla model versions as well, but it's in the category of a luxury sports car, and therefore we are comparing with a low price electric vehicle. We are comparing the Honda Civic with a Nissan Leaf. Now, if you talk about how much of fuel you need for 100 kilometers, and how much of electricity you need for 100 kilometers, right? And then you talk about the price for that, right? And over the period of 5 years, let's say you are going to run for 1 lakh kilometers, right? And then you add the 1 lakh kilometers, multiply with like divided by 100 kilometers and multiply with the 7 liters, and you calculate the price of fuel for that many liters, and then you add that running cost as well for the lifetime of the vehicle, and you also do kind of maintenance and everything cost added here. They are not considered. You also take into account what is the resale value, which is not considered here. But if you take the initial price and the running price, right, or initial cost and the running cost into account, the total cost of ownership for, let's say, for example, 5 years for Honda Civic, which is around 66,000 US dollars. Nissan Leaf, even if it is electric vehicle, it is just falling near to that, which is 63,000 US dollars over the period of, let's say, 5 years or 8 years. So this is obviously a better value, but how far? What is the difference? 66 and 63, just 3,000 US dollars compared to 66. So not much of a percentage. 3 divided by 66, that's not a really great percentage, right? So when I talk about total cost of ownership, right? Buyers are looking at uh, a very large difference, right? So yes, obviously there will be a large difference if you talk about BMW here, and if you talk about a Nissan Leaf here, right? If you talk about Honda Civic here and Tesla Model S here, right? So there will be a huge difference, but we should compare the same category and same class of the vehicle for the total cost of ownership. So let me give you the idea. Total cost of ownership is on-road price and running cost and maintenance and battery life or battery replacement, as well as end of life price also included. Okay, so if you do this exercise, you come up with a number that if I own the vehicle for 10 years from now, I'm going to spend around, let's say, 5 lakhs. Okay, so if you are going to own a two-wheeler for the next 10 years, you may be spending something around 5 lakhs rupees. And provided you are driving that many kilometers, right? And if you are going to own a similar electric two-wheeler, and if you are going to own that for 10 years, and if you ever come across a battery replacement, and if you come across a resale price, then which vehicle is going to be more beneficial to you? So that's what is called total cost of ownership calculation. So I hope, guys, this information is useful to you. You learned something new today, where you can actually compare two products. Like, and this is not only for electric vehicles. You take a, for example, you take anything, right, where you can do it for IC engine as well as hybrid electric vehicle. And if you take hybrid electric vehicle versus electric vehicle, you can do this similar exercise for any two similar class and category of the products. Now, the other point from my side is actually why the more efficient, why the next level of technology should not be costly, right? Why people are worried so much about the cost of electric vehicle? Isn't that, let's say, when we talk about EVs are very efficient, if you come across with a very efficient thing, it's obviously going to be very costly, right? If you think of a ball pen, right? If you have a very basic ball pen, it may be costing you 5 rupees or 10 rupees, but ball pens are available in the price of 200 to 500 rupees as well. So it all depends on what you have, right? So in my opinion, the customers are going to consider the overall cost, but if EVs are offering more, right, and that is where the last point comes, right? The last point is there is a large scope of making the EVs better, and therefore EVs can be a clear winner over the IC engine based vehicles. So if EVs are able to do a lot of things, and if EVs are far more efficient, the customers will definitely think of buying it, even though they are costly, only because of the advantages that it is going to offer. So this is about the comparison and in terms of cost. So let us now go to the next slide and let us see how we can start knowing about electric vehicles. So this is what is an electric vehicle. Okay, so these are the parts of an electric vehicle. Okay, so let us talk about this diagram. And this is a pure electric vehicle architecture where you can see these are the wheels, where I'm writing here as W. And these are, let's say this is a front wheel drive. And I'm assuming these are the front wheels and the vehicle moves in this direction. So this is a front wheel drive, and where we have a gearbox here. So this is a, let's say, gearbox or a differential unit, and where the motor is mounted, right? So here, let me write, this is a motor and this is a battery. Okay, so electric vehicles will have mainly three components: battery, a motor controller, through which the motor is controlled, and you have a gearbox and the vehicle body, right? So this is a simple electric vehicle architecture. And electric vehicle architecture is very, very simple in terms of number of moving parts. Okay, so guys, any idea on if you are taking an IC engine based vehicle, how many number of moving parts will be there in the powertrain of IC engine type of a vehicle? So I would like you to answer the question, how many moving parts or how many parts which will go on rotation when you run your vehicle which is based on IC engine. So any ideas on how many parts which are rotating? Naneshwari is saying 3. Okay, why not power converter? Amit Kumar, power converter is not a rotating part. Sharon is saying crankshaft, propeller shaft, and differential only. There's 3. Allen is saying 20. Okay. Sajal is saying around 25,000 parts. Okay, great. Wheels, flywheel, gears. Okay. Yes, interesting answers. So, okay. So when you talk about an engine assembly, entire engine assembly, right? It's basically going to be a lot many parts, right? And if you just dismantle all of these parts, right? There are probably more than 1,000 number of parts which are going to rotate, right? And when I say more than 1,000, it's all dismantle in all dismantle conditions. So when I say engine, it's just a one part. Then I cannot count it as a one part just as an engine, right, unit. So inside the engine and inside the power transmission system and a lot of other things, there are many moving parts inside an IC engine vehicle. So, but in the case of an electric vehicle, how many moving parts? Only the motor and a fixed gear ratio, which is a transmission system. So these are the only 2 moving parts. Obviously, there will be, let's say, power windows. There will be wipers. There will be a lot of other moving parts elsewhere. But when we talk about powertrain, right? When we talk about battery to wheels, right? We have only 2 units which are rotating. Okay, so therefore, this is another reason why EVs are more simple and EVs are more efficient, because there are no wear and tear, right? And motors can actually rotate for quite a long time. And ideally, EVs are maintenance free. There is no maintenance required. Obviously, with the help of technology, it is going to be the right thing, right? If it is a technology which is not mature, which is not proven, then there will be a lot of bugs or a lot of problems, and then it will need definitely a good amount of maintenance and repair as well. So only 2 parts in EV which are rotating. This is quite interesting. And thanks guys for your answer. Let us go next and let us try to understand what is actually inside an electric vehicle. So here I'm showing all the components which are inside an electric vehicle. So I hope guys this is visible to you, and just have a look at this once, and I'm going to explain you all parts one after another, and just try to compare this with the previous slide where I have shown you only battery, motor, controller, and the gearbox. Now we have actually many other parts as well, right? So I'm going to talk about this a bit after. I'm going to give you some time to have a look at it and try to check out how many components are there inside an electric vehicle. Okay, so Prashant is asking, if it's a DC-DC converter, why are we using it? Okay, great question. I will explain that. Okay, Pratik is replying, Pratik, no, it's not for motor purpose. Okay, so let me answer which are the parts and what are the role of each and every part inside an electric vehicle. So what basically is an EV architecture? When we say it's very simple, yeah, although it's going to be a little complex, but not as complex as engine and not as complex as many rotating parts. Okay, so the very first thing is about let's say the motor which is used for driving the wheels. Okay, so the motor which is used for driving the wheels is let's say here, right? So it's called electric traction motor in the red color, and the shaft of the motor will be connected to the transmission system here, where you can see. So normally EVs do not need a complex gear mechanism, right? Because the speed torque characteristics of engine are quite, uh, let's say, complex, and they need a gearbox, right? And EVs, instead of changing the gears, you can easily change the speed and torque of the motors, and therefore the transmission system here is going to be a fixed gear ratio or a fixed transmission system, right? And so the electric traction motors are one of the unit, which is a major unit. And how do you supply these motors, right? So the electric motors are going to take the supply from a power electronic controller. And this power electronic controller in the blue color, you can see as a box, which is going to take the power from the battery, where you have a traction battery, right? So if I give a numbers, right? Electric traction motor is number one, which is coming just after wheels, after transmission system. The transmission system I would like to name as zero, and wheels are basically, let's say, minus one, or we can see the output of the vehicle. And number two is going to be the power electronic controller. Number three is it is going to take the power from the traction battery pack, which is beside the where passengers are sitting, right? And it's arranged in such a way that it distributes its weight, right? And there are a lot of advantages of keeping the battery there, right? Instead of there is a lot of space here, but sometimes by putting the batteries over there, it improves in the center of gravity of the vehicle and better handling of the vehicle as well. And you need a less distance wires, right? So if you have a battery pack over here in the rear compartment, you need to take those wires to the front, right? And there will be a losses in this heavy, and the cost of the cables will also be high. Then why not here? Yeah, here we have a lot of other blocks, right? And therefore, this is one of the configuration. People are trying to put the batteries and motors even in the rear part as well, right? Which is a rear wheel drive as well. So if I give you an example of India's electric four-wheeler, which is a first electric four-wheeler, Mahindra E2O, right? So E2O is one of the vehicle which has a rear wheel drive, which uses an induction motor in the rear wheel, and it's not a front wheel drive. So this is just an example. It may be front or rear. So these are the three components or four major components which I have explained. Why DC-DC converter? It is an interesting question. So usually this traction battery pack are high voltage, and people have seen the advantage in using this type of high voltage battery packs. And when you use high voltage, yes, only this I'm talking about Reva, which is the earlier version of E2O. So basically, when you talk about uh, electric vehicles, right? You have a high voltage electric vehicle battery pack. Why high voltage? Obviously, there are some vehicles, for example, E2O, which uses a 48-volt battery, but you cannot run 48-volt system, right, to run your infotainment system, right? So for your car infotainment system and headlight and everything, right, and auxiliary loads, right, they are all called as auxiliary. You need a 12-volt supply because automotive 12-volt headlamps are easily available. Automotive 12-volt car infotainment systems are available, right? Automotive 12-volt power window systems are already available. So why to design them again for a high voltage such as 400 volt, right? So DC-DC converter is basically going to reduce that 400 volt of high voltage traction battery pack into a 12 volt or 24 volt or whatever suitable system. Normally it is 12 volt system, and therefore it is going to convert that higher voltage into lower voltage. And this lower voltage can actually feed the auxiliary load. Okay, so I hope this way you have a better idea about why DC-DC converters are required. So let me see if we have any questions. So there is one guy who has raised the question. Okay, Ajinkya Giri is asking why onboard charger. Okay, so how do you charge your vehicle? Is through onboard charger, and when you have a traction battery pack, it is going to be fully discharged, right, after you finish running your vehicle, right? And therefore you need an onboard charger which is going to take electricity from this blue cable here, right? This is a blue cable here which takes a AC input, right? And this onboard charger is basically an AC to DC converter, and this AC to DC converter will take the grid energy available, right, or a power system supply available from the network, right, and it will convert AC into DC. This is exactly equivalent to your laptop battery charger, right? How you charge your laptop battery? You have a travel adapter, and that travel adapter, if that travel adapter is inside the laptop itself, right, then you call it as an onboard charger. But usually this travel adapter will be bulky and you cannot accommodate inside the laptop, and it generates a heat as well. It's a power converter device. Therefore, you normally keep it off the shelf, right, or outside of your product. For example, your cell phone battery charger or your laptop battery charger. But in case of a vehicle, you are not very sure about there will be a DC charger available in the charging station, right? And it may not be suitable to your car, right? So all the car batteries are different types of chemistry, different voltage level, and different method of charging, right? So how do you know about where can I plug in my car, right? So an onboard charger is going to help you to charge your car anywhere where the single phase or three-phase AC supply is available. So that's about onboard charger. I hope you got the idea about this. And okay, so Parag is asking thermal cooling system. Which parts actually cool? Okay, so yes. So Parag, there are two things where you need a cooling, right? And this cooling we are talking about actually the cooling of the components like power converter, battery, and motor. So all this 1, 2, and 3 components are actually going to require some kind of cooling. Okay, why? Because they are going to lose some heat. They are going to be less than 100% efficient, obviously, and they are going to have electrical losses, and these electrical losses are going to come out as a thermal losses or a heat loss, right? So when you charge your laptop battery pack, it gets heated up, right? So heat is basically generated from the losses of electrical and electronic components. And in order to extract this heat, right, if you do not extract, the temperature will keep on increasing, which is not good for the life as well as the safety of the electric vehicle. So you need to keep the temperature in control, and therefore the thermal system, usually the cooling system, is required to cool down 1, 2, and 3 components, all electrical components, which is battery, motor, and power converter. Even when you charge, when you start charging your vehicle, you might have seen a sound of a fan, right? A charger fan. So whenever you start charging, there is a cooling required for charging as well. And what another type of cooling is required? Another type of cooling is basically HVAC. So it's basically your air conditioning system for the passengers, right? So the cabin temperature is also required to be controlled, and therefore you need a cooling as well. And somebody was asking why there are two radiators. Yeah, so the two radiators are for that purpose, right? So there are two types of cooling. One is the cooling required for components, which are powertrain components like battery, motor, and power converter. And other type of cooling is required for cabin cooling or passenger cooling, which is called air conditioning unit. Okay, so this is about electric vehicle architecture. And let us now go ahead and let us now talk about how is the energy flow, right? So let me share with you about what is the energy flow and what is the actual block diagram of an electric vehicle. So I'm sharing an important slide here where we say about flow of energy, right? And all those parts in the dark black color, they are going to be electrical, right? Where you talk about electrical energy, and then here you talk about mechanical energy as well. So let us try to understand what is the energy flow. So in simple terminologies, what is the energy flow, or what is the starting point, and what is the final point? So if I talk about a pure electric vehicle, the flow of energy or the energy storage is in terms of battery, right? So battery is where the energies are stored, and the energy or the power is going to flow through all the components in between, and that is going to be available on the wheels. Okay, so battery to wheels is the entire chain of energy flow. Now here, when we are considering the battery, we are actually ignoring a whole lot of other parts where the EVs are supplied from, right? Where the batteries are charged from. Okay, so we are going to talk about the stages from battery to wheels, and there is another. Okay, so how many of you? Let me ask a yes/no type of question to you all. How many of you think that EVs are actually the green technology, and there is no pollution, and that is why it should be promoted, and that is why it is better than IC engine based vehicles? So how many of you feel that EVs are green technology? Okay, great. uh, so Gautam says yes, Ronak no, Sonu says battery is a chemical. Okay. Mm, not fully green. Yes. Okay. Nikhil is saying not fully green. Okay. Great. Here we have a good combination of yes, no. It's not 100% green. Prem Pratik is saying it is green technology. Okay. So there is a lot of debate where EVs are green or not. Okay. And it can be altogether a different level of discussion where we say that no, EVs are better for environment, and some people say no, EVs are not better for environment. So till this point of time in today's session, I do not claim at all EVs are green and clean, right? Yes, EVs actually take power from the grid or the power system network, which is basically going to generate power from the coal-fired power plant, right? So in a way, right, you are not using that green technology unless and until your power generated in the power plant is green. Okay. So what is another way of looking at whether EVs are green or not, right? So people actually talk about carbon emissions, right? And there are a lot of studies happening with the CO2 emissions. So if you talk about CO2 emissions, when you talk about the petroleum, when you have a petroleum in the, let's say, the area in which there is a reservoir, and when you are going to extract the petroleum, and when you have a plant or a factory or a refinery where you are going to take petrol and diesel out of petroleum, you actually emit a lot of carbon. And when you are going to burn this fuel, probably there is a lot of carbon dioxide which are emitted. And there are people who are studying about CO2 emissions related to EVs as well, right? So when we are talking about the energy flow, I'm talking about the energy flow within the vehicle. Now, what is the energy flow outside the vehicle, right? So probably, and if you talk about that efficiency, right? So let us forget about the carbon dioxide. Let us focus more on efficiency, because that is what going to matter a lot, right? Otherwise, the green and the clean technology is just a kind of debate issues for environmentalists, but for engineers, it's basically how much is the overall efficiency that you are going to provide to the customer, right? That is going to be a question. So if we talk about the efficiency of all the stages, so let's say your battery is going to be charged by a charger, right? And your charger is receiving the power from a distribution system. I'm writing here as a DS, and CH stands for charger. So charger, distribution system, then you have a transmission system, and then you have a power plant. Okay, and then you have energy stored in a coal or some fossil fuel, right? So when you talk about coal to battery, yes, there is a lot of amount of inefficient stages, right? Even when you talk about the power plant efficiency, it is basically in the range of 25 to 35%. When you talk about transmission system and distribution system and the charger itself, which is AC to DC, there are a lot of energy losses here, right? And this is something which we call as a well to wheel efficiency. Okay, so whenever we talk about efficiency of electric vehicles, it is obviously high, but it is high from battery to wheels, right? So when we talk about battery to wheel efficiency, it is very high. When we talk about well to wheel efficiency, it is very, very low, or it is somewhere near to or just above the IC engine based vehicle. What do I mean by well? Well is something where we have a reservoir of a petroleum, right? So when you talk about the energy stored inside the fossil fuel, like coal over here, or let's say if you have a power plant, which is a diesel fired power plant, right? So well to wheel efficiency is still low for electric vehicles. So I hope you guys have now clear idea about what we are talking about. So we are not talking about well to wheel efficiency. We are talking about battery to wheel efficiency. Okay. And let us try to understand what happens from battery to wheels. Okay. So this is a battery unit, and let's say it has some amount of charge stored, right? Some amount of energy stored. And this much amount of energy is going to help the vehicle to move for some distance. Okay. Now, whenever you supply this battery, you basically have a positive and negative terminal of the battery. And when you connect this positive and negative terminals of a battery to your power converter, you will have losses within these wires as well, right? So let us take an account of where all losses can happen. Okay, so we are going to now take an account of where are the stages where the losses can happen. So from battery, we do not, we assume that there are certain losses which are happening, which is self-discharge. Okay, so here, let's say in an entire week, I'm going to run my vehicle for 100 kilometers, and every day I run for only 15 kilometers, right? So just after running the 15 kilometers per day, I'm going to park my vehicle in the parking area and there will be a self-discharge. Okay. So even if you are not using your cell phone, over the period of time, its battery is going to discharge, and that is called a self-discharge. So there are losses in terms of battery as well, which are known as self-discharge or leakage losses. And the power converter or the power control will also come up with its own losses, which are basically the losses in terms of heat, right, or the thermal losses. So these are losses similar to when you charge your cell phone battery or your laptop battery. That adapter, where AC to DC converter is going to get heated up. Similarly, this power control modules are inverters, right, and DC-DC converters. This will also get heated up, right, and there will be some efficiency level, and the remaining amount of power will be available as heat, right? So when I talk about this, let us say the efficiency one is the battery self-discharging efficiency. Efficiency two is the power converter and control efficiency. And now this power converter and control will be supplying this through a three-phase wire. Let's say if the motor is three-phase, and the motor is going to convert electrical input energy into output mechanical energy. So these are mechanical output now, these two. And the motor is also going to have some level of efficiency, let's say eta 3. Gearbox is also having efficiency eta 4. And finally, you have vehicle body or the wheel. Okay, so I'm not going to consider any efficiency here. This is a gearbox efficiency eta 4. So if this is the energy flow and this is the overall kind of power flow, right? How much is going to be the overall efficiency from battery to wheels? So let us take a calculation of battery to wheels efficiency. So now I'm going to give you some numbers. Guys, if you can get ready with your calculator or maybe a pen and paper, it will be great. You will be able to answer this. So what is my battery to wheel efficiency if my efficiency one is, let's say, 95%, right? So first level is 95%. Then I have the next level, which is power converter, which is, let's say, 85%. Then the next is the motor, which is efficiency 3, which is, let's say, again 85%. And gearbox is a mechanical unit, and let's say its efficiency is 80%, right? Let me erase this and type again, 1 minute. So the efficiency 4 is 80%. So can you guys help me to kind of understand what is the overall efficiency? So efficiency 4 is 80%. Now, if I take from start to end, how much is my overall efficiency? Can anyone help me with this answer? So I repeat the question. Efficiency for the battery, efficiency 1 is 95%. Next stage efficiency 85. Motor is also 85% efficient, and gearbox is also 80% efficient. If this is the efficiency at any operating point of an electric vehicle, how much is the overall efficiency? Somebody saying 86, 89.25, 54, approximately 55, nickel 60. Okay, great. Yeah, so I see many of you are trying this. Great. So let me tell you, how do we calculate this? Okay. So I'm going to open up my calculator. Okay, 1 minute, guys. And I hope you can see my calculator. Let me clear. Oh, I think I cleared everything. But yeah, I remember what numbers I have taken. So uh, the very first battery is 95% efficient. So I'm going to write here 0.95. So I just want to take numbers instead of percentage value, right? So then if we have a cascaded, hey guys, am I audible? So I'm assuming yes. Okay, thanks Alok and Vikas for confirming. So I have efficiency of 95% for battery, and if my next stage of power converter is 85% efficient, the overall efficiency of these two units is going to be multiplication of these two, right? So whenever you have efficiency of cascaded units or cascaded stages, it is basically the multiplication of previous and the next stage. So I need to multiply this with 0.85, and I need to again multiply the result of this two with again 0.85, right? So this is again 85% of 80 value, and again I have 75% efficiency for gearbox. That's what I guess I have taken it. So if I multiply this with again 75%, my overall efficiency is 51%. Okay, so this is uh, the value of the overall efficiency. Okay, it was 80. Oh, okay, okay. Maybe if you take 80.6863, let me correct it, 0.6863 multiplied with 0.8, right? This will be 54.9. Yes, so 54 percentage is the overall efficiency. And now this is the percentage efficiency for the given typical numbers, right? When I say my battery is 95, it may be 95% over the week if I'm going to ride only 10 kilometers or 15 kilometers in a day. But in one shot, if I'm going to ride 100 kilometers, right, then my battery efficiency is not 95, it will be 98. Power converter, it depends on how you are operating, right? If you are applying good accelerator pedals, right, and if your let's say your efficiency value for that loading condition is higher, then probably you have a higher efficiency here as well. So it depends on all operating conditions, right? So when I now define, so whatever you calculated, it's not actually the overall efficiency at which the vehicle operates, right? This is just a simple calculation to know about what happens in a cascading, right? When you have one stage after another, what is the effect? So the overall effect is your overall efficiency from battery to wheels is going to be lower than the lowest. Okay, so you just need to remember this. Your battery to wheel efficiency is always going to be the lower than lowest. So if you have thought of a gearbox which is 75%, or we have taken it as 80%, the overall efficiency is going to be obviously less than that, right? So the overall efficiency in terms of cascaded stages, it's going to be lower than the lowest. And when you have efficiency 1, 2, and 3, and 4, which are actually not a constant numbers, they are going to vary a lot. There will be a lot of variations in terms of, let's say, loading condition, in terms of operating conditions. So these numbers are actually going to fluctuate a lot. Okay, and how these numbers fluctuate, how these values rise and fall, right? That depends on how you are operating. So what is a motor efficiency curve, right? That is going to define all these values. What is a power converter efficiency curve, right? How your gearbox changes the efficiency with reference to speed and torque, right? That is going to define all these values. Now, how your values are going to change, that actually is being driven by how you drive your vehicle, right? So how you drive your vehicle is called a driving pattern, okay? Or in more technical word, it is called a driving cycle. So your driving pattern or your driving cycle, basically, which means your accelerator and the brake commands from the user, right, is going to decide all this efficiency, right? And therefore, your efficiency is going to be a function of your speed, right? Your efficiency are basically the function of or I will say they are proportional to the speed and the torque, right? And it's proportional to environmental condition. It's proportional to how you are operating, right? It's proportional to what is the aging effect of the motor, right? And there are a lot of factors. So the overall efficiency of the entire vehicle depends on how much at what speed you are running your vehicle, right? And it is quite visible from, let's say, IC engine based vehicle as well. So if you are going to have a highway drive, right, and if you are going to have a city ride, right, where you have a many stoppage, right, and your speed cannot go above 40, right, and in highway, let's say you are driving continuously your two-wheeler at 60 kilometers per hour, your highway mileage is obviously better than your city mileage, right? So it all depends on your how you are driving, how is your curve, or what is the relation of motor efficiency with speed torque, and how you are discharging and charging the battery as well. So the overall efficiency depends a lot on this. And let me tell you, this efficiency, which was just to be calculated, was 55%. It can go as low as 30%, which is the top efficiency for an IC engine, which can go as high as overall 85%, right? So let's say we assume that in an electric vehicle, the efficiency varies according to speed, and that variation is minimum 30% and maximum 85%. This is a battery to wheel efficiency. Now, if you have to estimate how much is the amount of battery required for this vehicle to run for 100 kilometers, it's going to be a very difficult task, right? How do you estimate what amount of battery capacity is required for this vehicle to ensure 100 kilometers? So that is what you have to understand, and you need to take all these things into account and then probably estimate this. Okay, so I hope you got a good idea on what is the energy flow and the efficiency. And people are working days and night and to improve the efficiency of the motor system just by 2%, right? There are a lot of researchers who are working, a lot of engineers who are working to increase the power converter efficiency just by 5%, right? So if overall efficiency of an electric vehicle is to be improved, all the stages efficiency has to be improved, right? And because the overall efficiency is going to be lower than the lowest, right? So in order to do that, all this should be simultaneously functioning well and simultaneously functioning more efficient. And when they are going to, how are they going to function more efficient? And it depends on the loading condition, it depends on their own characteristics. So therefore, it is very much necessary to know about how they are working, right? And therefore, you can actually estimate the capacity of the battery for a typical value of distance, right? And so this is about energy flow and the efficiency. I hope you guys are clear with this. Let me go ahead and talk about how you should start working on EVs, right? How you should start learning about EVs. Okay, so the very first thing is fundamental concepts. So the domain knowledge on the following systems or following subjects is very much required. So you need to be very thorough if at all you are very much interested in EV technology, and if at all you guys are kind of looking for your career in EV, or let's say EV is something really excited to you, how you should start working on it, how you should start learning this is by developing or by enhancing the knowledge on the following systems. So these systems are number one, which is a vehicle mechanics and the vehicle dynamics. Right, you need to understand what is the speed and torque required on the wheels. Right, you need to understand what is the speed and torque characteristics of a motor as point number two. And you need to understand how power converters are going to control the motors and therefore the vehicle, and how power converters will be controlled digitally through a microcontroller or a microprocessor. That is number four, right? So if you have a thorough understanding of all these four basic subjects, right, you are very much comfortable with the fundamental concepts. Now, it is not only about learning all these fundamentals separately. It is about learning all these four together for the Eevee application, right? So if you are electrical and electronics undergraduate student, or if you have passed out, you must have learned all the subjects separately. But Eevee is kind of a subject or an application where you learn all the subjects applied for each other, right? So when I say Eevee, it's basically one, the subject knowledge of one applied with two, applied with three for the application four, right? And therefore, you need to understand this. So guys, I will be getting the charger to plug into my computer. Please hold on for a while. Sorry for this pause. So you need to understand the interdisciplinary subjects. Let's say, for example, how control systems are applied to power converters, how power converters and motor together act as a drive, and how motor satisfy the speed and torque requirements on wheels, right? So if you understand all these four together, you will be kind of thorough with the fundamental concepts. Now, is it only fundamental concepts required to start working on this or start learning about this? No. You need to also have a software tool knowledge. Let's say the very simple thing which I talked about, the cascaded stage-wise efficiency, right? It is very difficult to understand. If I ask you, let's say you're going to run in a typical pattern for 5 kilometers, how much is my energy consumption? If I ask you to calculate this, it is basically a very heavy calculation, right? And you need to talk about what is the efficiency at different speeds and how you are running your vehicle. And you probably need to do many calculations multiple times, and therefore you need software tools, right? So if you are able to do the efficiency calculation just like 1 multiplied with 2 multiplied with 3, there is no need of a software tool. But if I ask you to calculate this efficiency and find out the overall efficiency by taking 500 seconds, by taking 1000 seconds into account, then it's a quite a complex calculation, and you need to do it repeatedly, right? And it will be tedious for you to do manual calculation, right? And you need to write a script or you need to do a modeling, right? Or you need to either type a program or you need to do your own model which iteratively calculates everything, right? So the second important thing is you need to understand the software tools in a better way, right? You should be used to the software environment and you should know how it works in the background. And the very important thing is here, you should be able to translate a scenario into a simulation situation, right? And you should be able to implement an idea and learn from the results. Okay, so this is how you can actually start working on this. And when you start working on this, you actually come to know about these things like where is the scope of improvement and where these things are not going to be separate, right? If you do not know subject fundamentals, there is no need of knowledge of on software tools, right? And when you know fundamental concepts, you go to software tool, and when you have results, you come back to the theories again, right? And then you try to verify your results. right? So it's going to be a two-way process where you learn the fundamental concepts, apply the software tools, get the results and comment on the results and try to modify the things, right? So let's say some of the modification may be higher power rating of the motor, right? And some of the modification after doing the software simulation is, let's say, a better control strategy, right? It's an iterative process. Fundamental concepts in the software tool goes hand in hand when you want to start learning about this. So I hope this is clear to you guys. And let me go next. So next I'm going to tell you the importance of simulation and what is basically a simulation. So guys, can anyone give me an idea what is a simulation? What is an example of a simulation? So yes, Ajinkya, I'm going to take up a lot of questions. Just let me finish. This is the last slide from my side. Yes, Nikhil says games, correct. So video games are the best example of a simulation. So all of you must have at least played one of the game, let's say where you are running a car or where you are a pilot and you are flying a plane, right? So virtual training, yes, where you are, let's say, talking about if you want to train a pilot, yes, that is called a simulation. So simulation is just something where you need to understand how real world scenarios are developed and how you can replicate the same system, right? So if I want to do an EV simulation, right, why should I do an EV simulation? So yes, Moinuddin is correct. Reception of a scenario or virtually creating a scenario, which is a real world scenario. Yes, because you are right. So why should we do a simulation for electric vehicle? Why can't we build one? Prasad is saying range estimation, correct? Destructive testing is costly. Yes, without physical damage. Okay. Gaurav says to know about the losses. Okay, without wasting a lot of money. Okay, great. Yes. So yes, it will also save the time. Yes, you are right. So EVs are, if you want to learn about EVs, definitely you should start from simulation. Okay, and why about only EVs? So let's say you are learning about power converters and AC to DC rectifiers, and you want to check the waveform on oscilloscope, right? Whether you're getting a DC voltage or not, and you want to use a multimeter to measure this. Now, before choosing the diodes, before giving that single phase supply to your circuit, you need to understand what is the capacity of each and every component. Are you going to compromise on the safety of components? Are you going to get the correct output with this value of components, right? Then you need a circuit simulator, right? And if you have a lot of other systems, mechanical systems, electrical, electronic, and control systems, you need a system level simulation, right? Or you need a system level simulator. So therefore, simulations are very useful, and mathematical models are not actually suitable for initial experiments. So all the products which you now see, right, it can be a refrigerator or a washing machine or anything. There has been a simulation behind that, right? Just after the idea or just after the starting phase of the product design, there will be one or other type of a simulation. And actual system realization may be very costly and time consuming. Many of you have already said, and therefore you need a simulation. And how does a simulation work? You need to understand what is a practical result, what is a physical experiment, or what is the physics behind that scenario. And you need to convert that into governing equation, which is called a theory. And if you have those governing equations implemented as a program or implemented as a model, then you can prepare or you can use this models in order to do your mathematical model. Okay, so if I give you a best example of electrical engineering, where let's say you want to simulate a simple register. Okay, so you have a register and you have a physical experiment on that register. Okay, so you do a physical experiment in the laboratory where you record the value of I, you record the value of voltage, current, you have an estimation of R, and you record a temperature rise as well. If you are going to apply more voltage, it is going to take more current, and there will be I square losses, and the temperature is going to rise. Okay, if temperature is going to rise, the resistance is also going to change. Now, if you have done this experiment, and if you have governing equation, which is established in terms of Ohm's law, or it is established in terms of resistance change in terms of temperature change, right? And how again resistance changes with the temperature. And then you can use these equations as a mathematical model to apply any voltage, right? So in the laboratory, you might have applied only 10 volt, right? And you might have developed a heat of only 1 watt, okay? But in a simulation, you can actually see what is going to be the change in the resistance if your resistor is going to dissipate 100 amount of watts, where the 100 amount of watts was never possible practically, right? So this is where a simulation tool is going to be very, very useful in your learning. And you do not need an actual laboratory-based equipments, right? So in a way, your simulation is actually replacing your lab exercise or your lab part, where basically what you do in a lab, you basically want to derive the governing equations, and you want to check all this, right? And there will be obviously a closed loop where once you have done your simulation, once you are confident that, okay, this system is going to run, then you go with a laboratory setup or a hardware setup, and you go to the real world and do that experiment or do that practical with your first vehicle, right? So this is how the simulation helps in learning the system, and this is how it will be useful. So this is the end of my today's presentation, and what exactly we are going to learn tomorrow. Let me take that before I before I allow you all to ask the questions. So here is a day 2 agenda. So tomorrow, same time from 4 to 6, we are going to learn about what are the battery technology and what is the meaning of power and energy density of a battery. And we are going to actually see the MATLAB and Skill-Lync, and I'm going to demonstrate Eevee battery pack simulation with MATLAB and Skill-Lync. So tomorrow I'm going to kind of help you learning how to build a model where you kind of run your simulation setup for electric vehicle batteries. So that's about tomorrow's agenda. And till this point of time, or till this presentation, if you have any questions so far, right? If you want to ask any question, then I'm going to take your questions now. So, okay. Thanks, Animesh. Thanks, everyone. Ashok, no, we will not be able to provide you with this PPT. Thanks a lot, guys. Okay, so so Pushpak is asking a question. In a car, both onboard and offboard chargers are available. No, Pushpant. So basically, inside your car, whatever is a charger circuit available, that is called onboard charger. Now, what is the meaning of offboard? Offboard is something which is outside the vehicle, okay, and which is basically at your charging station. So if you have a DC charging station where you have your AC to DC power converter inside the charging station, then you just need positive and negative supply, right? Or positive and negative terminals to be connected to the battery terminals of your vehicle. And there, that particular charger is called an off-board charger. So off-board chargers are something which is outside the vehicle, which is available at a charging station location. So I hope this is clear. And there were a lot of questions related to simulation tools and softwares. Okay, so guys, feel free to type your question here. Tirindana, I'm not able to understand your question. Can you please be more clear about your question? Okay. So Shiva is asking if there any reinforcement technology concept, driverless car concept is ability to adapt with EV technology. Yes, obviously, Shiva. So, Shiva, if you know about how your steering mechanism works, do you have any idea on how steering mechanism works? So nowadays, the recent cars will have powertrain steering mechanism, right? Sorry, electric power assisted or EPS, right? Usually we call it as an electric power steering. So electric power steering can be controlled just like how the motors are controlled, right? And you can actually do the left and right, and you can have a control over the brakes as well, right? So it's very much possible with the digital things where you want to increase or decrease the speed, you want to change the left and right. These things are quite possible if your vehicle is more adapted towards electronic things, right? And electric vehicles are best controlled in the way where they are they are electronically controlled, right? So with EV, as we discussed, there is a shared mobility associated with that. With EV, there is a autonomous or drivers freedom is also associated with that, and that is also quite easy in terms of making it autonomous, right? So if you think of an IC engine based vehicle, you want to make it autonomous, you need to control an engine which is basically a mechanical entity or mechanical unit. If you want to make electric vehicle autonomous, which is easy because it's battery operated and it's motor controlled, right? And yeah, it is possible. So Shahan Moham is asking about what is the simulation software used in EV vehicles. So Shahan Moham, it's basically up to you what exactly you want to simulate, right? So let's say if you want to simulate let's say aerodynamics, right? Probably you need to use a different software package, or if you, let's say you want to simulate a circuit, which is your power converter circuit, then you need to have different simulation software. So electric vehicle is interdisciplinary thing, and probably there are obviously more than 3 to 4 different types of software used in entire development of EV. Right? So when you want to do computational fluid dynamics for battery cooling, there is a different software. If you want to do let's say how your motor is designed, then you need an electromagnetic solver, something like ANSYS Maxwell. If you want to do a system level study, you need to definitely use something like MATLAB and Simulink. And if you want to design, let's say PCB, probably you need a different type of simulation software. So yeah, so P. Sharan is asking, what if I'm ready to invest on EV? How can an OEM guarantee me on cybersecurity? Okay. So Sharan, nowadays, okay, I think cybersecurity is the next level of question, and probably this vehicles are more secure in terms of cyber attacks and such a thing, but there are no guarantee provided in terms of your vehicle is very safe, right? Even if you talk about IC engine vehicles, they are also coming under the same thing, right? Where let's say you have an emergency braking system, or let's say you have a airbags, right? So if some hacker is going to come, and even if your vehicle is IC engine vehicles, he can play with your airbags, right? Even under no emergency conditions, your airbags can come out, right? If it's basically a digital communication network which requires to be penetrated. So to some extent, it is not different than a IC engine vehicle. But yes, for electric vehicles, there are no OEMs going to give a guarantee that it's not hackable, right? So at present, what OEMs are providing guarantee, they are providing guarantee on motors and the batteries. That is something what customers are looking for at this moment. Vivek is asking about anything about H2O fuel cell. Okay. Yeah, I think there is a good scope for hydrogen vehicles as well. And yeah, there are a lot of people showing interest in that. For example, in India, there is a Toyota Kirloskar, which is doing that. So Toyota is a company which will be looking for both EV and hydrogen-based or fuel cell-based vehicle, where Toyota Mirai is one of the example of hydrogen-based or fuel cell-based vehicle. So is DC-DC converter come under motor controller part? No. Prasad, DC-DC converter is a different unit, and it's not motor control. If your motor is permanent magnet DC motor, right, and which needs a variable DC power from a fixed battery DC supply, then yes, your motor controller is a DC-DC converter. But if your motor is a three-phase motor, and if you need a three-phase output from a power converter, then your motor controller is basically inverter. So I hope that answers. Okay. Franklin is asking 2030 forecast. MHEV is 15%, battery electric vehicle is 14%. Why is that? Okay. So Franklin, I basically believe that EVs will be much more than HEV because they are far efficient, right? So if you talk about, let's say, hybrid electric vehicle, you still are dependent on petrol and diesel, right? So what is the difference between EV and HEV, right? In terms of generating the electrical energy, right? Can anyone answer this? I think that will be very much helpful for Franklin. So HEV, when we talk about hybrid electric vehicles, they are kind of self-dependent on their own because they have the power plant on board. Okay, what is a power plant on board? Instead of your electric vehicle battery, which is going to be charged from a very big power plant, which is situated very far from your house or your charging point, you can actually have an onboard power plant, right? When we talk about onboard power plant, what is your power plant? Power plant takes a fossil fuel and generates electrical energy. The same type of unit can be there, which is called an engine, and it can generate electricity, and it can generate mechanical output power as well. So MHEV, in a sense, it's a combination. It's obviously a good option, but it's not going to be that efficient. So if you talk about the practical vehicle, for example, Maruti Suzuki Ertiga, it comes in two variants. So the Maruti Suzuki Ertiga is, let's say, for example, going to give you 20 kilometers per liter mileage in best operating condition. Maruti Suzuki Ertiga mild hybrid version can give you as high as 23 or 25 kilometers per liter mileage. But ideally, the customer would need, let's say, 40 kilometers per liter or 50 kilometers per liter, which is possible with a full hybrid vehicle, but it will be very costly, right? So in my opinion, EVs are going to be better than MHEVs and therefore, or PHEVs, and therefore basically going to capture a lot of market in future. So I have a lot of questions. Can we have both current in traction motor? Yes, Gaurav, if you are asking about AC and DC, there are both types of motor used in electric vehicle. There are few motors which are AC, there are few motors which are DC. So which is the best motor for EV, AC or DC? So Jay, there is no final answer because there are motor developers or there are motor design engineers who can say that my DC motor is going to be more efficient than your AC motor. And there are people who can say that I have more advantages of using AC motors than a permanent magnet DC motor. So it depends on what type of motor you are talking about. But as of now, permanent magnet being not a constraint in terms of rare earth and the raw material supplies, permanent magnet DC type of motors are more preferred than AC induction motors. So Gautam is asking reliability of EV and can they run lakhs of miles like IC engine? Oh, great. So Gautam, I would like to answer this in two ways. So there are people who are counting on miles of electric vehicles, and people have not yet registered or not have come up with any kind of result of lakhs of miles. But yes, IC engines are more reliable, and I can say they are more mature technology. But if you talk about an IC engine, how many times an IC engine is going to fail to start, right? You talk about a normal condition. So let's say IC engines are 500 years or 300 years old technology, right? Probably some scientists or some engineers might have done a very basic experiment on IC engines, let's say 200 years ago. Till 200 years from now, that technology has matured, but even today we are facing problems with IC engines where we cannot start it, right? Where we fail to start it in the first attempt, right? So that level of maturity, EVs are going to take up in a while, but obviously there are problems with IC engine, there are problems with EVs as well, but over a period of time, EVs can be more reliable than IC engines for sure. So how does liquid cooling work for EV? So Prem Pratik is asking this question. Basically, we do not allow the liquid to flow and to be in contact with the electrical equipments. So there will be isolation, electrical isolation, and the liquid, the cool liquid will be flowing and it will be extracting the heat from those components, and it will be exchanging the heat, right? And therefore, the liquid cooling is going to work for EVs. Shailesh is asking how to build career in EV and PGHEV. So Shailesh, I think I covered the last two slides where I was explaining about how to start learning about EVs, right? And that's where you need to focus. Let me go back to that slide. So you need to focus on these two things where you are working on the fundamental concepts and you are knowing about software tools as well. And I would like to answer this to promote Skill-Lync courses. So if you are interested, you can take up Skill-Lync master's program in electric vehicles and hybrid electric vehicles. That way you are going to cover both fundamentals as well as software tools, and you can get into this domain. So Skill-Lync courses should be the right choice for you if you want to get started with this. Okay, so Alvin Paul is asking about my project is solar powered hybrid bicycle. Okay, thank you for giving me a chance to hear you. Okay, thanks a lot, Alvin. Wish you all the best for your project. Ether has regenerative braking. Okay. Which circuit is used in BMS? Okay. So tomorrow we are going to learn something interesting about the battery management system, and uh, it's not a power converter actually. So there is no such circuit used in the BMS. It's basically you should ask a question in the form that uh, what kind of um, let's say algorithms, or what kind of conditions are checked inside a battery management system, right? So battery management system is more of a software than a hardware, and it's basically kind of a configuration of your vehicle parameters. So Sandeep, yes, we have AC motors as well. So let's say, for example, Mahindra E2, it uses an induction motor, which is AC motor for electric vehicle application. Akash is asking embedded system design engineer scope in Eevee. Yes, there are a lot of scope. Whatever you see, whether it's a motor controller or a battery charger or a battery management system, they are example of an embedded system. So there are a lot of microcontrollers, there are a lot of hardware, PCB design and everything. And yes, embedded systems engineers are very much required in EV companies, right? So obviously there is a good scope, I would say great scope for the person with such a embedded system hardware and software skills. So when you are an embedded engineer and probably let's say you are working on a set-top box application, or let's say you are working on audio and video image processing, or something related to home automation, something like that. But in EV, you need to know about powers, right? You know about power systems, where specifically power electronics and machines, and then work on the embedded part, right? That way, you need to have a combination of skills, right? So it's not only you should know about embedded C programming, you should know about entire system. So which type of battery is more efficient? So Arun Krishna, we are going to answer this tomorrow. Um, Ganesh Niravati is asking, is noise cancellation possible in IC engine vehicles as it is max at its max efficiency? So yeah, there are some efforts happening in that direction, but Ganesh, I'm not very sure in that area that refers to the noise, vibration, and harshness of IC engine. I'm not very much sure about that. Okay. Atmala Subramaniam is asking, boot space make every more weight? No, I don't think so. If your vehicle is going to have a more boot space, that doesn't mean it is going to be of higher weight. So Ajinkya Giri is asking which software is used in BMS. So tomorrow you are going to get some idea about what is a BMS and what is inside a battery management system. And basically, it's not a software, let's say, where I can say MATLAB and Simulink is used for BMS, or I will say um, Plex or PSIM or any mechanical software like SolidWorks is used for software in BMS. No, it's not like that. So battery management software is going to be written in, let's say, embedded C, or it can be written in a model-based simulation software such as MATLAB and Simulink. So basically, it can be embedded C, or it can be any other higher version of embedded system programming. So battery management system software is basically embedded system software, or embedded system supply. So whether can I say my project as hybrid? Yes, you can say your project is hybrid, Alvin, because you are using more than two sources. You have a solar as one input, battery as another. What people call as hybrid is basically the mixture of two, right? If you talk about education, when we say due to the Corona pandemic, we are having online education. And if you have the classes running, you have an offline education, and you can actually have a mixture of two, which is hybrid, right? So for some type of uh, learning, you can do it online, and for other type of work, let's say if you want to appear for a test or if you want to do a practice tutorial, you can go to the class and do the offline. It's hybrid mode, right? Uh, in terms of vehicles, Alvin, you can consider, let's say, your CNG vehicle with a CNG kit. That is also a hybrid vehicle, right? But when we say a hybrid electric vehicle, it's basically going to use a battery energy storage system. Okay, so yes, you can call your project as a hybrid, but it's not going to be engine hybrid. It's going to be two types of energy storage systems, or two types of energy input system, one solar, another battery. So a scope of thermal engineering EVs, yes, there are very good scope of thermal engineers in EV. If you know how to design heat sink, if you know how to cool down those important PCBs or important electronic, right? You are the right person in EV industry. So there are CFD engineers for battery pack cooling. There are CFD engineers for power converter coolings, and there are CFD or thermal engineers for motors as well. So when you design a motor, you need to do electrical design, electromagnetic design, and mechanical design, which is for fabrication, and you will do a thermal design as well. So thermal design is very important part of all electrical components in it, and therefore better scope. Gaurav is saying yes, Tesla use IPM. Correct, yeah. So once upon a time, Tesla was using induction motor, and due to the belief that one day the rare earth magnetic material will be a scarcity, and the price of the permanent magnet material will be also high. But they have realized the advantage of using permanent magnet over induction motor, and so actually they are using both. They are using induction motor as well. They are using permanent magnet motor as well. Any communication protocol. So Atmala, there are a lot of communication protocols. Controller area network is one of the um, protocol or one of the communication system used in EU. Apart from that, you will find I2C, you will find SPI, you will find even Ethernet as well, and you'll find wireless communications as well inside electric vehicles nowadays. So, but the most popular soft communication protocol is controller area network. So DK is asking why PMSM motor, why not BLDC? So yeah, there is a good comparison of these two motors. So BLDC motor basically um, uh, produces the torque in terms of pulses, while on the other hand, permanent magnet synchronous motor will be more smooth torque, right? And there are a lot of advantages of control, and you will definitely get a better efficiency in terms of PMSM than BLDC motor. So yeah, that's what about this comparison. Is fixed battery concept or swapping concept? Okay, Maruti, this is a really interesting question. So if you have recently heard of some of the two-wheelers, right? Let's say Ather Energy, they have a fixed battery concept. So I'm talking about the vehicles in which it is possible to swap the battery, right? It's if you are talking about a four-wheeler or a bus or a truck, there are handling issues, and the battery is of high energy capacity, and if you are moving a fully charged battery inside a four-wheeler or something like that, it's going to be a dangerous thing, right? But people are talking about swappable batteries for two-wheelers, and yeah, it's a successful concept. But in my opinion, it should be a swappable battery or a flexible battery where customers can easily replace and take a fully charged battery. So which technology is good? Obviously, there are pros and cons of that. Swappable is definitely going to help the customer, but you need to design a battery where you are allowing the customer to take the battery, but it should be safe, it should be theft proof, it should be kind of let's say designed in a way that if the customer is going to handle in a rough way or not properly, then also nothing should happen to your battery, right? So those ways, it's challenging to have a swappable battery pack design. So yeah, okay. So Nishit Kumar is asking about what is the difference between EV masters and master's course in hybrid electric. Okay, let me tell you, Nishit, about this. So wait a minute, I will go to Skill-Lync website and answer this question. So I hope my screen is visible where I'm sharing a Skill-Lync website. One minute, guys. Yeah. So if you go to skilling.com here, and if you go to courses, right, there are courses related to mechanical engineers and electrical engineers. So the primary difference between hybrid electric vehicle masters and electric vehicle masters is the mechanical and electrical domain, right? So if you belong to mechanical domain, you should go for hybrid electric vehicle. If you belong to electrical electronics, you should be taking electric vehicle masters. This is the difference in terms of what should be your background. But what is a course content? So let's say if you want to learn about how to design a motor, if you want to learn about how to design a power converter, how to design a PCB, and if you are interested in writing embedded C code, if you are interested in microcontrollers and control systems, you should definitely go for EV masters. And if you are a mechanical engineer, you do not have any background, right? You haven't learned any subjects such as electrical machines or power converters, which usually electrical engineers will learn in their bachelor's. You should take hybrid electric vehicle masters. And the difference is if I go to hybrid electric vehicle masters, you will get exposure to some extent about electric vehicles, right? And the remaining of the thing, right? You are going to learn according to your domain, right? According to your interest. So if you are taking a hybrid electric vehicle masters, you are going to learn about electric vehicles in these 3 courses. And these 3 courses are system level overview, right? Or system level understanding and system level simulation of electric vehicle. We are not going into depth of how to design a motor, how to design a power converter, and how batteries are going to be designed, right? We are just going to see how the EV works, okay, how electric vehicle technology works. And if you are satisfied with how it works, then you should take, and if you belong to mechanical domain, you should take these 3 courses where you take idea about electric vehicle. And if you are interested in diving deep into design of motors and design of power converters and design of control systems and embedded systems, then you should take an EV master's program. Okay, so I hope this is clear with you. And so which Skill-Lync course would go well for graduate in control systems? So Siddharth, you should take up EV master's course because in control systems, if you have a graduation in control systems, you can learn quickly about circuits, you can learn quickly about electrical machines and embedded systems. So I will recommend if you have control systems background or electrical electronics background, you can definitely go for electric vehicle masters. Okay. Saurabh Jadhav is asking when it will finish. Okay. Yeah. So guys, I'm going to take a few more questions now only. If you are interested, you can stay back. So one interesting question from Anurag is, I'm BTech student from electrical electronics. Yeah, you can consider, you can have a look at Eevee Masters program. So, okay, Muhammad Ashik is asking how long will it take to implement the charging station in India? Okay, so, okay, Muhammad, let me ask you a counter question. How many electric vehicles are there in India? Okay, so this is a question like who is the first, chicken or the egg, right? So I'm assuming, in your opinion, charging station should come first and then EV will come, right? But actually, when EVs are there, then charging stations will come, right? So, yeah, and it's a uh, supportive process, or you can see it like the other way, right? If there are no charging stations, no EVs. If there are no EVs, no charging stations. And then you can also look at like if there are few more EVs, then there will be a couple of charging stations coming up. And then if there are more EVs, there will be more charging stations. So they are dependent on each other. It's a cyclic thing, and you need to understand uh, on what basis it depends on, right? So if I ask you how many 4G towers in India, right? Well, that depends on companies, right? How many companies are interested in making 4G towers or installing 4G towers? Now, how do they, how do the company people or how do the company management decide that they want to install the next technology towers in India? They decide on the prediction that there will be a 4G users in India, right? So based on the prediction of EVs, there will be a EV charging stations coming up. I hope that answered your question. Can automation engineer have scope in EV? Yes, Parag. So if you are instrumentation and control or automation background graduate, you can definitely take up EV Masters program where you learn about uh, kind of uh, interesting things such as control systems and embedded systems, which you will definitely like. So Maruti Ram is asking, we have three concept in APCT three-wheelers. I would like to know about that technology. Okay, Maruti, I'm not sure about your question. So Apache, I'm not sure about what you're talking about. Okay, there is a company for electric three-wheeler, and yeah, there are some variants. Basically, those variants are based on what is a motor power rating, what is the speed, right? So there are some three-wheelers available at 25 kilometers per hour, and you get a subsidy on that based on government regulation of speed below 25 kmph. And there are certain three-wheelers which are heavy three-wheelers which are as equal as your normal IC engine based three-wheelers. So their top speed can be 60 to 70, and their payload can also be around 500 kilograms or something like that. Yeah, so it depends on the power rating. So those variants of electric three-wheelers are based on power rating. Can we decrease the charging time? Yes, it is possible to have a fast charging battery. It depends on the battery chemistry and how you do it. So there are nowadays there are companies which are allowing you to fast charge your batteries, not every time, but once in a 10 times charging, right? So if we use solar panel for battery charging, then what will happen? Yes, Kalaisaran, you can actually charge your batteries from the solar panels as well. So okay, so thanks a lot, guys. And Shruti, I think I have covered most of the question. And okay, let me check with last two questions. So Gaurav Payal is asking, can we have many motors in traction chamber where few work as dynamo and few work as motor, or something like wise to have very less dependency on grid power supply? Okay, so this is an interesting question. So Gaurav is asking about why can't we have, so if I talk about this, so Gaurav is saying that we have a motor unit, right? And this motor is going to take power from the battery, right? And the shaft of the motor is connected to the wheels. Okay, so this is battery. I'm assuming there is a power converter, but and there is a motor shaft connected to the wheels. Okay, so let's say here is a block called wheels or mechanical power transmission or axle. And why can't we connect another shaft, and why can't we connect a generator here, right? That way we are going to produce some electrical energy, right? And probably we can use another battery, or we can connect this generator output to the same battery and save some energy, right? So guys, what do you think? Is it not possible to connect a generator on the another shaft of the motor, and while the vehicle is running, this generator will also run and it will charge the battery as well? What do you think? If you can answer your opinion, it will be really great. So I will be waiting for some time. This is really interesting. So it is possible to do like this, but look at from where the generator is getting the energy, right? So when you supply the energy, let me use a blue color. When you supply the energy, it goes through motor and it goes through wheel. And when you supply the energy, it goes through the motor and you are running another generator and it comes back here. So in this loop, where the energy starts from here and comes back to here itself, there are two elements which are having some efficiency. So let's say this gear efficiency is eta G and the motor efficiency is eta M. So you are actually losing your battery capacity, right? It's better not to travel, not to allow travel that much of energy to pass through motor and generator, because it's always going to be less than one, right? Or less than 100%. So why don't you keep it within the battery, right? So when you try to do this, actually your generator is taking back energy from the battery itself, right? It's not going to be a magic where you produce the energy from nowhere and you capture it in the battery. It's not like that. So in my opinion, it's not a good idea to do something like that. Some people think of like installing a wind system on the vehicle body, right? And if you have a wind system on your vehicle body, those wind blades will rotate and you can produce some energy. But if you have those wind blades, right, you are actually increasing the aerodynamic drag, right? And if you increase aerodynamic drag, it's going to ultimately result into more energy in the battery, right? So it's not going to help, right? I have seen some people doing experiments on Tata Nexon Eevee. With on the top of it, they have installed a small windmill, and they are going to produce some power. But yeah, it's ultimately going to affect your battery because you are increasing the air drag of the vehicle. So I hope that answers your question. And, okay. So is there master graduate program in universities on Eevee? Deepak, there are very few masters program in universities. But yeah, Skill-Lync offers one such master's program. Which master is better for instrumentation and automation? So the energy, we do not have any master's program in industrial automation or something like that, which we may come across them in future. But we have a EV Masters program and Power Converter Masters program, which are relevant to instrumentation and automation. Provided you like the subjects like electrical machines and power converters and embedded systems. So, okay. So thanks a lot, guys. Um, and okay, so Viprata is asking about regenerative braking systems. Should I go for it, or there is need for some electrical engineering subject background? Yes. So Viprata, if you are looking for a project on regenerative braking system, you will definitely need the help of electrical and electronics engineering. So thanks a lot, guys. So that's it from my side.